Sorry. Good evening, stargazers. I hope you can all hear us. Hi there. Good evening, stargazers, and welcome to the first live streaming of National Astronomy Week 2025. And we've been preparing a lot for you tonight. We've got clear skies in certain places and often surprisingly clear skies in some places. We've got cameras in 4 different countries, and so we are pretty sure that we will be able to bring you some clear views of the moon and planets. So let me tell you what's up in the sky tonight. We do have Saturn, but I'm afraid Saturn is a bit too low for any of our telescopes to get onto. Then we have the moon. It's a thin crescent moon. Those of you will with clear skies will be able to see that there is a lovely thin crescent moon just below the planet Venus. And so the moon is the thing that is going to set first. So we are going to look at the moon and Venus as soon as we can. And then we have also got Jupiter high up in the sky and Mars high up in the sky. And so we will leave those until a bit later. Now, Mars and Jupiter both are, as I say, high in the sky, and they're both completely different planets in terms of their appearance, as is Venus. So we will be able to compare and contrast. So I'd like, first of all, to introduce you to the first one we're going to go is to David Arditi. I don't know if David has still got clear skies. He is down in Edgware in London. And David, what's the sky like where you are at the moment?
Hello, Robin. Yes, well, the sky is surprisingly enough still excellent here. And I can see the moon and Venus, and the earth shine on the moon is very beautiful because the crescent moon is such a thin moon that you can see the light reflected off the earth back onto the moon, and that's the earth shine, or the old moon in the new moon's arms, as it's called in folklore. And that is just below the planet Venus, which is most bright thing in the sky at the moment. and I have my 14-inch telescope trained on Venus, so I can show you the image that the telescope is producing.
Yes, we've got that. Great.
There it is. So the right hand is the image, and the left hand is the controls, obviously, where you can alter the sensitivity of the camera so I can make it brighter and so forth. And you'll see it's moving a lot and it's quite blurry, and there are a multitude of reasons for that. So it's very low in the sky, so we're looking through a thick layer of atmosphere. And the atmosphere refracts the light, and it refracts different colors differently. So it pulls the red light further from the horizon than it pulls the blue light. It pulls all colors away from the horizon. And so that's why you see a red edge to Venus. That's not its natural color. That's an effect of our atmosphere, and all that movement is an effect of our atmosphere. And Venus is generally, we see it low down in the sky because it's one of the inferior planets. It is closer to the sun than we are. So we're always looking somewhat in the direction of the sun to see Venus. So we have to wait for those occasions when it sets after the sun and we view it in the evening sky as we have it at the moment, or sometimes it rises before the sun and then we can view it in the morning sky. And at the moment, we're close to what is called the greatest eastern elongation of Venus, which is when it is high in the western sky after dusk. And you'll see it's a crescent. I haven't mentioned that so far. That's a pretty obvious thing. It's a crescent like the moon, except this is actually inverted because the telescope inverts everything. So if you saw it directly, the crescent would be the other way around, like the lunar crescent. And of course, the phases of Venus are very similar to those of the moon, and it goes through the full cycle of phases. When it's on the far side of the sun, which is the situation known as superior conjunction, the full Venus would be visible if the sun were not in the way and if it were not so close to the sun in the sky. And then as it comes round towards the eastern elongation, it goes through a half phase, which we went through about 4 weeks ago. And then the phase shrinks. And as the phase shrinks, it becomes bigger. The angular diameter of the planet gets larger, becomes easier to distinguish. So even with good binoculars, if you can hold them steady, you wouldn't, in the next few weeks, you'll be able to see Venus as a crescent phase. It doesn't take very much magnification to see that. And it gets bigger and bigger, but the phase gets smaller and smaller until it comes round to what we call inferior conjunction, when it is getting between the Earth and the sun. And then we almost see the dark side of Venus completely. In other words, we can't see it at all. Occasionally, Venus can actually pass in front of the sun, which is a transit of Venus, but that only happens exactly. It only goes exactly in front of the sun twice every century, roughly. In general, it passes above or below the sun. So it's somewhat frustrating object in that it's always close to the sun in the sky, and when it is large diameter, large angular size, it is a small phase, so there's not very much of the surface that you can see. But when I say surface, we don't actually see a surface of Venus. We see the top of an extremely dense cloud layer. And there is not much in the way of features that you can see on Venus through a telescope other than the phase. Sometimes you can see a little bit of shading in the cloud layers, but it is not particularly striking. But using telescopes, we can view Venus in non-visible wavelengths. We can image it in ultraviolet and infrared, although I haven't got the camera on the telescope today that does that. But it is possible to see different layers of the clouds of Venus using filters and cameras sensitive to ultraviolet and infrared light. And in that way, amateur astronomers with small telescopes, or relatively small telescopes, such as the one I'm using, small, when I say small, it's actually quite a big telescope. It's 14-inch in diameter, but small compared to professional telescopes. We can see details on Venus as we can on the other planets. And we can even see some of the surface details in the far infrared by looking at the dark side of Venus when it's a thin crescent. And by overexposing the bright part of the planet, we can actually, at certain wavelengths, start to see the dark side of the planet, which glows with thermal radiation. The night side of Venus glows, and we can see actual features on it on the surface. But this image, this white light image, is show the color and colored image is showing the tops of Venus's clouds, and it's wobbling. One of the reasons, other reasons it's wobbling around is actually I've got buses pass on my street, and every time a bus goes along, you can see that in the telescope image. It's like a very sensitive earthquake detector. But the bus has gone now, and so it's calmed down a bit.
Yes, David, I think people might be interested to know why sometimes it's quite steady, not just the jiggling about, but the fact that it gets very blurred at certain times. And that's due to our atmosphere, isn't it? The little blobs of hot air or whatever. Any comments about what might be making the difference?
It's probably aircraft, because to the west of me, well to the west, we've got Heathrow Airport. So we've got lots of planes around, and they even occasionally come through the field of view of the telescope. So when a contrail is nearby, that's going to be higher temperature air, and that's very noticeable when you get a contrail going through your image. That really disturbs it. So this is what astronomers call it seeing. The seeing is the steadiness of the atmosphere. So ideally, you want to observe planets when they're high in the sky, and also certain weather conditions give us better seeing. Settled weather with high pressure tends to give better seeing, whereas if you've got windy conditions with different flows of air at different altitudes, at different temperatures, that gives disturbed seeing. And you see this more and more as you magnify the planets more, and that is really imposes the practical limit on how much we magnify planets. You can magnify a planet a great deal with a telescope. It's not the extent to which you can do so isn't limited really so much by the telescope, but it's just beyond a certain point, and there's no point in it. But if you put your telescope on a high mountain, as professional telescopes tend to be, then you're looking through less atmosphere, and you get a steadier seeing. Another thing we can do with Venus is we can observe it during the daytime. During the daytime, it's higher up, and it's actually bright enough to be seen in the daytime with a telescope, and then you can get possibly better seeing. But you have to be very careful with that. You have to know what you're doing, because using a telescope in the daytime is always risky. You need to take the correct precautions so that you cannot possibly point your telescope at the sun, which would be disastrous for both your eyes and your equipment. So that's important to mention, that if you're using a telescope in the daytime, you really have to be careful and know what you're doing.
Yes, so the image would be a lot better if you could observe it in a lighter sky when it's higher up, even though normally we observe planets when it's dark, but in the case of Venus, it's a very bright planet. So it's certainly easily visible when it's a lot higher in the sky at twilight. At the moment, it's actually only about 18 degrees above the horizon, and I know you said it was about to disappear into a hedge. So I think we're lucky to be able to catch it there.
Yes,
Thanks very much, David, for showing us that. I'd like to move on now to Andy Devi, who's down in Spain, and see what he can show us, because he has got the moon in his telescope, which is it's slightly higher than Venus.
Good evening,
Hi,
everybody.
Andy.
Welcome, or bienvenido de España. Welcome from Spain. Okay, so at the moment, I am using a Takahashi TOA 130 refractor telescope, and I've coupled it with a Saturn M mono camera, which is quite a large chip camera. I'm actually showing an image here at 5-meter focal length, but because the atmospheric scene has dropped off quite a lot over the last half an hour, I'm only showing you an image size of 25% of what I'm actually grabbing. And for high resolution images, we would normally shoot up to about 1,000 frames, take the best 10%. I use a program called AutoStackit to effectively with smoothing out the effects of the atmospheric shimmer, which you can see at the moment is it's blurring. The large crater that you can see in the center of this image is Mare Crisium, and I believe it was formed during the heavy bombardment period. And what I will do shortly, I will do a fly across the surface of the moon, which I'll start doing now.
The heavy bombardment was not recent at all. That happened
No,
about
3
3.5 billion years ago.
Yeah. So don't worry too much about that. But there is a theory that Venus and Saturn swap position, and it was something to do with the gravitational pull that caused a lot of comets and asteroids to come in and not only hit the moon, but what you've got to remember is the Earth was it a lot more than what the moon was, but the moon has no atmosphere, so the only erosion that you get is from other impacts covering the older ones. Now, if you look inside Mare Crisium, just before I move off it, these are later impacts. I'll keep moving down. Sorry. Keep moving down. As you can see, the atmospheric scene, it comes and goes. And if we want to do a large, high-resolution image of the moon, which the biggest one I've done is an 80-panel mosaic at 4-meter focal length, we have to we have to basically work our way across the moon, taking video clips. Then we run it through. I use a program called AutoStackit, and then I drop the finished TIFF files into Registax wavelets. So the images that we can produce digitally are far better than what you can physically see through your camera or with your eye if you're using an eyepiece. Now, nighttime astronomy is not my speciality. I'm one of those lazy astronomers that loves the sunshine. I am a solar astronomer, and I moved to southern Spain to pursue that particular passion that I've got. And when I finish doing this tour over the moon, I'll just show you some interesting parts associated with what we can see and capture on the sun in all its glory. So I'm just going to quickly go to the other part of the image that you're seeing. It's like David and Robin told you before, they are inverted images because our telescopes flip the image. So
it's also actually back to front, isn't it?
Yeah, it is. Yeah.
So both upside down and back to front because of the mirrors used in the system. Yeah.
Yeah.
So if you're looking at the moon with a pair of binoculars, you will see it the other way up. The crescent will be the horns of the crescent will be facing to the left instead of to the right.
Yeah.
And it will be inverted. So but astronomers get used to that, and we just have to know which way round it is at any one time.
We've mentioned atmospheric seeing. Unfortunately, the lower down a target is, and David had it with Venus and I've got it with the moon, the more atmosphere we look through. If we look vertically up through the atmosphere, you're looking up through approximately 10 miles of atmosphere. But if you look at 10 degrees above the horizon, you're looking through about 120 miles and all the dust and all the different air pockets. Now, seeing, you'll notice it a lot if you're doing solar astronomy. If you get a cloud approaching the sun or going over the top, you get the dense atmosphere underneath the cloud. And if you're doing solar astronomy, I'll just stop sharing this at the moment, and I'm going to go on to the PowerPoint. Okay, so I've just put my location there. I'm not far from Almeria, so southeast Spain. We've been near Oaxaca for 11 years, but in Spain for 13. That's me at the side of the rig I'm using. So here, that's the TOA 130. I've got a guide telescope for deep sky, and then that's a 90mm Coronado CAK telescope, and that's a 90mm Hadron Alpha telescope.
Some pretty impressive kit there. CAK means that you're observing in the light of calcium atoms on the sun.
That's correct. Yeah.
Hydrogen alpha, the light of hydrogen alpha, which is a deep red color, isn't it? That's the sort of get those prominences around the edge. And
I'm just going to stop sharing a second because for some reason I'm struggling to advance this this slide.
Yes, it happens with PowerPoint sometimes on Zoom. Yep.
Yeah. I'll just try again. Right.
Now the size of your telescope, it's a 130mm, which is it's actually quite small compared with David. It's only just about 5 inches aperture.
It is, yeah.
Is a C11, C14, which is 320 millimeter, about twice, over twice the size, in fact.
Yeah. Right. I'm just gonna. I'll try again. See if it's is that advancing?
Yes,
the slide?
That's
Excellent.
changed now. Yeah.
Panic over. So I've designed and built my own telescope observatory, and it's basically a 2.4-meter cube that runs on rails, and I need my telescope outside without any hot walls of a roll-off normal roll-off observatory, which would destroy my solar seeing. So that's just a quick view. I use a laser pointer for acquiring my targets. I've got GOTA, but sometimes, specifically if you're using high focal lengths, it can make acquiring targets quite difficult. So that's a 3-meter by 3-meter moon photograph, which consists of over 4 billion pixels. And that represented about 30 hours work putting that together. This is one of Saturn I did a few years ago, because at the moment the rings have closed right up, so that's why Saturn looks a lot dimmer, because you're not getting any light reflecting from the ice rings. I'm passionate about animating, and that's an animation I did of Mars rotating back in 2018, and you can see the southern polar ice cap there. This is one I did of Jupiter. This is at 5-meter focal length on 18th, so just shy of a fortnight away, and you can see the moon Io just moving in and starting to transit. And
yes, this is speeded up, of course. It doesn't really move as fast as that.
Very much so, yeah. And you can see the great red spot coming in just below the southern equatorial band. And obviously that's the northern equatorial band. But also, if you look at the frames of that image, there's no difference in focus, but it's the atmospheric seeing during recording that can make an enormous difference in the quality of the image that you develop. And when you run them in animation, it highlights that. Now, if anybody's got a standard DSLR camera, can you see the Milky Way here? That's a Milky Way transit in the sky, and you've actually got Jupiter and Saturn following it on this one. And for me, these little thin clouds, they just make the video or the image a little bit more interesting. This is my southern sky, and these are the Sierra Cabrera Mountains. This one I did 2020, and that's if you watch here, comet Neowise setting on my local town, which is Bedar. I'll just run that one again another time, which again, a tripod and a standard DSLR camera, and you're getting some nice animation and on astronomical themes. Very occasionally I do deep sky, and that's again using a standard DSLR camera put onto this TOA 130, and that's the Eagle Nebula. I showed you the three solar telescopes, and this is a comparison of white light, CAK, calcium K, and hydrogen alpha, all taken on the same day. I always put the date and universal time on it, everything, so it's all time stamped for scientific context. And this is AR 2192 from 2014, well, the 21st of October. And that was the largest sunspot in the last 30 years. And that particular one gave out 6 X-class flares, 3 of which I were able to record. Those actual images, although I've shrunk and put them together, they are a meter in diameter. Now,
Andy, I'd like to move on, if I may, now to the other end of the Mediterranean, where Agapios is waiting in Cyprus to show us.
Okay, I'll stop sharing.
Yeah, thank you very much indeed, Andy. We'll probably come back to you in a while, see how you're getting on. So,
hi, everybody.
Agapios Elia over in Cyprus, and you've got a very good setup there as well. What are your skies like tonight?
Well, I'm going to follow in Andy's steps and give you a greeting in the local language. So, Kalispera, από την Κύπρο. Good evening from Cyprus. Well, as you know, Cyprus is in the Eastern Mediterranean, a lovely island. We've been blessed with very, very good conditions. We have clear skies almost all of the time, such is the case tonight. I'm sitting outside, and it's a wonderful night. All the stars are out. I enjoyed looking at the moon and Venus before. They're set now for me. And I'm currently sitting outside next to my telescope, which you can see here. Now, this is a Celestron 9-inch Schmidt-Cassegrain telescope. So it's got a 9-inch diameter mirror, and it's coupled to an imaging camera very similar to the one that Andy was showing before. And now I'm going to try and share my live view. I'm currently imaging Jupiter, and I'd like to show that to you. There we go. Hope that's coming through all right.
Yep, we've got that.
Excellent. So this is the live view of the planet Jupiter right now. I'm currently zoomed in quite a bit, so you can see that the equatorial bands on the planet are well visible. It's not a very good night in terms of atmospheric seeing, which is what Andy and David were describing before. It's actually, I'd say, marginally poor, but we can still try and pick out some interesting details on the planet Jupiter. Now, Jupiter is the most dynamic of all the planets. Its appearance changes all the time. There's things happening every time you observe Jupiter. It's an amazing target for somebody who's looking into getting into more dedicated observing, and you don't really need a very big telescope to see a lot of things on Jupiter. Even with smaller telescopes, you can easily pick out the equatorial bands, the Great Red Spot, which is not that big nowadays. It's actually shrunk quite a bit. And you can also see the moons on Jupiter. We don't have them in our site right now, but I am going to try and open up the view a little bit so that we can try and find them. There we go. And I'm just going to increase the exposure on the camera a little bit. And there we go. We should be able to see one moon over here. And there was another one somewhere around here. There we are, off to the other edge. Now, the planets, as I said, they're very dynamic and things happen all the time. And such is the case on Jupiter. We're currently experiencing what's known as an outbreak on one of the equatorial bands, just on the top of one of the equatorial bands, just into the northern tropical zone. Let me see if I can bring this back. So what is happening now on Jupiter is over here. So what's happening now in this area of Jupiter, we have what's known as an outbreak. So there's a violent restructuring of the circulation of the air currents on Jupiter, and this is churning everything upside down, and the appearance of the planet is expected to change, possibly even dramatically. For those who have been doing planetary viewing and imaging over many years, the veterans, let's say, you might remember what happened back in 2010 when one of the main bands of Jupiter was hidden from you from one of these events. So it's really interesting to see how things develop on the planet over the course of the next few weeks, and see just how the view will change. So this is what I'm doing right now. I'm just taking some images, doing some processing in the same way that Andy and David described before, and trying to see what I can resolve, how many details I can see on the planet. And this is just one of those images that I did from before, and you can see these two bright spots. This is exactly where this new outbreak is happening. And over the course of the next few weeks, this is expected to change quite a bit, perhaps even cover one of the equatorial bands. We'll just wait and see.
That's really quite a nice image. And as you said, or as we've been saying, the crucial thing is not to put up with just the quick image. And for centuries, people, of course, did the best they could just by looking at Jupiter. But in the last 25 years or so, we have been using webcams which make it possible to record a video sequence of thousands and thousands of frames, and software, as we've been saying, can select just the best one. So will you be able to show us an image later on of how Jupiter actually looks with a bit of processing? That would be really good.
We can do that right now. It will only take a minute.
Oh, okay. Let's go for that then, because I think that's really fascinating to see how the image can be improved.
All right. So, so that's the live view. So currently we're shooting pictures of Jupiter, sequential pictures of Jupiter, or a video, at a rate of about 45 every second. But I want to increase that. So I'm just going to select a tighter area of the sensor and change my exposure so that I can record faster. I'm up to 100 now. It's that number right there. For those who don't know the software, this is the FPS, or frames per second. I'm at 108 right now, which is fairly okay for what we want to do now. And I'm just gonna record a 60-second long video, which will result in many thousands of frames. So there we go, we're recording now. The reason why the image is now turned black and white or monochromatic is because when we are recording, we don't need the color information. That will slow down the data transfer. So we're going to use software just after we finish recording to recombine the color information at the other end of the data transferring. It's a little bit of astrophotography magic.
I think so since you improved, I think you did. The image did sharpen up when you increased the or decreased the shutter speed, as it were. So that looks a bit sharper now than it did before.
Yeah, and of course the seeing is continuously fluctuating. So it's not uncommon to have monumental differences in sharpness and clarity within the span of a few seconds. There we go. So that's recorded now. We just collected our 60 seconds worth of information. And I'm going to go on to this software, AutoStacker, which will take that information, take that video file right there, and process it. So what we are going to do now is evaluate the quality of all the individual frames that we recorded. And here we get this very interesting graph, which is actually divided into three parts. We've got the grid in the back, which shows us our time. So on the left side is the beginning of the file capturing, and on the right side is the ending of the file capturing. We have this wavy pattern, the gray wavy pattern, which is actually the quality of the frames as they were being recorded. That's why it's random, going up and down, because we had good moments and bad moments all intertwined. And then the green curve is the result of the sorting that this software has done. So it's actually collected all of the good frames and brought them all to the front side of the file. So what we can do now is choose how many of all those we want to keep. And we usually go for half or a third of the total, just to keep the sharpest frames for our processing. And I'm just going to tell the software where things look nice and sharp. I'm using these green boxes called alignment points to tell my software where to sort of pay close attention and judge the resolution coming out of my system. And I'm also going to tell the software to choose about a third of the total number of frames. So now it's only going to collect that 30% of the better information and recombine that into the final image. Now, this is something that astronomers in the old days couldn't even imagine being able to do, especially back in the days of film. But now, with the development of these kinds of cameras, which can be very, very affordable, we have an incredible arsenal of very high quality instruments that we can use and pull out a lot of interesting information. So we did that, and I am now going to open another software, which we're going to use to sharpen that image that we just created. So let me just go and find that image. Okay, so this is the result of the combining of the 30% of the better information that we got. And I'm now going to go into sharpening. I'm using a sharpening process known as wavelets, and I'm just gently trying to tease out more information. And I don't know if you agree, but that's
pretty good.
Right. That looks all right.
Amazing transformation, isn't it?
Yeah, it can get better. Let me see if I can play with the color balance a little bit with the levels.
I always think it's a bit misleading when we show people pictures like this and then they look through the telescope and say, well, that's pretty poor. It looks like a bowl of porridge compared with the lovely images which we show them. But it's worth remembering that all our knowledge until about 25 years ago was based on drawings and rather poor photographs taken with film. But now we can get these amazing pictures which are better than anything that any professional astronomer could take until these webcams came along, quite cheap webcams. You can see the difference there now between the live stream and the sharpened up image.
Exactly. The live stream is on the right side, this red window here, and this is the processed image. So this is hiding inside of this. It's just a matter of being able to collect it and sort through all the junk, let's say, of the atmosphere, and pull out the information that's hiding right there.
Well, Akapias, that's wonderful. I'd like to go over now to see what David's got for us over in Edgware in London on his somewhat larger telescope. It'd be very interesting to compare the difference between Cyprus and Edgware. So, David, what have you got?
Yes, I have Jupiter here. Here it is. So this is the live view. This is a live view of Jupiter from a 14-inch telescope in London with a colour camera. Jupiter is as high in the sky as it can ever get from the UK. It's about 60 degrees high. And the features that we can see there are the two main brownish belts, the North Equatorial Belt and the South Equatorial Belt. This is an inverted image again, so the North Equatorial Belt is the thicker one below the equator. And you can see smaller white spots in those belts, little white spots in the zones. The zones are what we call the lighter coloured areas between the dark belts. And the dark belts are quite permanent. They sometimes change colour if you monitor them over years, they can get thinner and thicker. They change their latitude slightly, but the structure of the belts is roughly fixed, whereas the spots come and go, particularly the small spots. Of course, the most famous spot is the Great Red Spot, which is the longest lived spot. It's been observed for about 150 years at least. But that is unfortunately on the other side of the planet at the moment. But I expect that on some of the other nights of National Astronomy Week, we will be lucky enough to catch the Great Red Spot. So it's important to say that Jupiter is entirely gas. It is a gas giant. It's the biggest planet in the solar system. It's 13 times the diameter of the Earth. It's round about 400, 500 million miles from the Earth. At the moment, it is closest to the Earth. It doesn't vary that much, but it is closest to the Earth because it's in the condition called opposition, which is where it is opposite to the sun in the sky. And when it's close to opposition, then it is rising when the sun sets and setting when the sun rises. And so it's visible all night, and that's the case with Jupiter at the moment. It's visible all night. It's due south about now, and it's about 40 arc seconds in diameter. Astronomers measure the size of objects in the sky in arc seconds or arc minutes. And so to give you an idea, the moon is half a degree in size, and there are 60 arc minutes to a degree. So the moon is around 30 arc minutes in size. So Jupiter is an arc second is a 60th of an arc minute. So Jupiter's around about a factor of 40 or 50 times smaller than the moon. So if you saw them together, which occasionally you can do, Jupiter would just be the size of a small crater on the moon. Nevertheless, with a large amateur telescope, we can resolve all these details on it. And these spots, that they drift around because the different parts of Jupiter rotate at different rates. And in general, the equatorial regions rotate faster than the polar regions. But there are different wind zones on the planet which go at different speeds, and these carry the spots around. And sometimes the spots merge, and sometimes, as Agapios is saying, there's a new outbreak of turbulence or spotty activity in a part of Jupiter where it hasn't existed recently. The Great Red Spot has been getting smaller in recent years. It is a big hurricane, essentially, and we don't really know why it's red, but it seems to drag material up from deeper down in the layers of Jupiter's globe, and somehow reactions of chemicals with the sun probably produces the red color, but despite the visits of space probes, it's not understood.
And I believe we'll see the Great Red Spot tomorrow if we can get to Jupiter. David, I'd like to move on now, if I may, to one of our other people who is up in Scotland, which is Mark Phillips. And I believe it's maybe just a quick one from you, Mark, to tell us what things are like up in Edinburgh at the moment.
Well, yes, as predicted, it is cloudy in Edinburgh. The forecast is better for later in the week. But I do have a little video here if you want to see
Yep.
that.
Okay, crack on with that.
The last few, just find it, there we go. The last few weeks have actually not been bad at all. So I've managed to get a few planetary things. So hopefully you can see that. I'm just going to run this video and I can stop it at various points if necessary. So we do have a telescope at the Astronomical Society of Edinburgh in Spain, but it's actually cloudy in Spain as well. So Edinburgh and Spain not really doing very much for us. But this is my observatory on the western edge of Edinburgh, and occasionally it is clear here. And this is my setup. So it is a 10-inch Newtonian, a 250 millimeter Newtonian, and this is what I've got set up on it at the moment as well, which is a 3x tele-extender, a filter wheel. This is a new thing to me, an atmospheric dispersion corrector, but this is a new one, which is an electronic one, which is meant to adjust itself automatically. Still to be decided if that's true or not, and also a camera similar to the other ones you've seen as well. And these are some of the things I've actually done over the last couple of weeks. And it's pretty much exactly as you've been seeing live tonight. So first of all, this is Mars. So this is what I would be able to show you tonight if it was clear. And it's dancing around in exactly the same way as the other planets have as well. And in the same way that Agapios did, I processed that image out of that video. You can see the North Pole cap at the bottom, it's upside down. Jupiter, just a couple of weeks ago as well, and there you can actually see the Great Red Spot. And when that's processed, using exactly the same techniques as Agapios, there you can actually see the Great Red Spot and the belts on Jupiter very clearly. Sometimes it's quite useful to use different wavebands. So this was done in infrared, and it can actually make the image steadier. And that white dot there is the outbreak that Agapios mentioned, and it stands out really brightly in infrared, and the moon Io stands out as well. Also, you can use a methane filter to look at Jupiter, and you tend to see features at different depths that way, but it actually makes it a bit trickier to process, but you can see features you might not normally get to see in normal color light. Venus, as we've seen already, is quite hard to do anything on, and that's pretty much the most I've got out of it. The dispersion corrector can actually help with that by sharpening up the different colors, but Venus still doesn't offer a huge amount. I think finally, these are two images, one done in color and one in red. These came out like those. So this is what you can see here at the bottom is an earlier storm that was discovered in November. It started out as just a little single white spot, and it's developed over the last couple of months into something that's really quite complex, and probably the latest outbreak to the north of the planet will do something similar as well. So that's what I'd hoped to have been able to show you tonight.
Well, I gather that we've got live images of Mars to show everybody now. So thanks very much, Mark, for that. That's some pretty good images there. So thanks a lot. Now, shall we go back to Andy in Spain then, please?
I've got a live image of Mars, just a second. Yeah. hopefully you can see that the winds are starting to get quite high where I am now. So I'm getting 25 km/h winds. That's one of the problems with living at the top of a hill. So I'm at an
Yes.
altitude of about 400 meters above sea level.
And this is a monochrome image, isn't it?
It's a
So-
monochrome image, yeah, but you can see the polar cap there. Mars is about 50 degrees altitude at the moment, so the scene's a bit better at this focal length. But you can see I'm getting quite a lot of atmospheric distortion. But if I were to shoot a couple of thousand frames on that, it would pick up a fairly decent image. But I've got a fairly old computer, so I'm not going to have no intention of processing it live online. So I don't know if anybody's got a color image that's. Have you got one from Cyprus that I can hand over, possibly?
Yes, Agapios, how's things with you?
Say no more.
Okay, here we go. Thanks
Okay,
very
I'll
much.
stop sharing.
Thanks, Andy. Thank you.
There we go. That's Mars Live from Cyprus in color. Right now, it's almost exactly overhead for me, so that's really good because we get the least possible atmospheric dispersion and the best possible conditions. And that's the live view. But I've just done a quick processing, and this is what I just got. So let me just pull that up next to the live view to show both side by side. So that's the live again on the right hand side, and this is the processed view of Mars. And Mars is also a very dynamic planet, much like Jupiter. We get dust storms all the time. We get the changing face of Mars. We get the shrinking or expanding of the polar caps. And I'd just like to maybe close with that the planets, even though they're a very restricted collection of targets compared to deep space objects. I mean, you can only actually observe 5 of them in any kind of detail. They're so dynamic that they change all the time that they're just so interesting. I mean, at least to me. We're able to follow weather patterns on neighboring worlds using home telescopes. So to me, that's extraordinary.
Yeah, that's a great image. Thank you very much. And you can see quite a bit on the processed image there. As you say, the bit at the lower right is called actually the Solis Lacus, which is also referred to as the Eye of Mars. Not so obvious at the moment why it's called that, but it is quite a well-known feature on Mars, and we're in a way seeing the blander side of Mars there over on the left-hand side, but in reality it is one of the most interesting parts of Mars because that is what is known as the Tharsis region, where there are several really big volcanoes, including Olympus Mons, which is the largest volcano in the solar system. And when Mars is a bit closer and slightly better seeing, you can actually start to see the volcanoes there. I wonder if we can go over to David in Edgware now and see what he's got on Mars. Thank you very much, Agapios.
Yes, Robin. There it is. So Mars is rising in the southeastern sky now, as seen from England. It will reach its highest altitude around midnight. It's close to opposition. And you can see the polar cap there. That's at the bottom there. That's the North Polar Cap, which is a mixture of water and carbon dioxide ice. And the polar caps advance and retreat with the Martian seasons. And Mars has seasons very similar to those of the Earth because it has an axial tilt. Its rotational axis is inclined to its orbital plane by about 24 degrees. So that's very similar to that of the Earth. And also its day length is very similar to that of the Earth as well. It's very close to 24 hours. So if you observe Mars at the same time every night, you tend to see the same same face of Mars, the same part of it, but it will advance slightly from night to night because its days do not exactly correspond to ours. And what we see, amateur astronomers call these dark features the albedo features of Mars, and they have these names like Mare Erythraeum, which mean means a sea, but they contain no water. They are just areas of darker rock on Mars. And as Robin says, we've got this lighter hemisphere of Mars that we're looking at mostly now, which contains some of the high volcanoes on Mars. And I can't particularly notice it now. Yes, I can actually. There's some sort of lighter patches you can see there are in the lower part of the disk. That's the northern part of the disk, but not as far north as the polar caps. Some lighter patches, and I think those are actually cloud that is forming over the volcanoes. You get thin clouds of water droplets in the Martian atmosphere. Mars atmosphere is only 1% the density of the Earth, but it still has weather, as has been mentioned, and the clouds tend to form over the morning terminator and the evening terminator. So when the temperature is changing, and also they're formed where winds blow over high ground, and you get the droplets coming out. And so we can actually, although I don't think we're seeing the mountains directly, we're seeing them indirectly in this image because of these light areas of cloud.
And one thing I notice is that as we're seeing, the right hand edge of Mars is just a little bit more fuzzy than the left hand edge. Partly that's due to the fact of the seeing, I guess. But are we seeing a bit of shadowing on Mars there, or is it fully illuminated at the moment?
It's close to fully illuminated, but it's a bit it's a bit past our position. So the left hand side, which is the western side in the sky at the moment, that would be the terminator side. So that is a little bit less sharp, but it's also looking a bit bluish in this image due to atmospheric dispersion. Although I've got a dispersion corrector on the telescope which corrects for that to a certain extent, but it's not perfect. So we've got a little bit of a blue edge on the terminator side.
And Agapios has just written in the chat here for me. He said David's feed is giving me aperture envy because you are using an instrument which is rather larger than his. And what is interesting is that everyone envies Agapios being in Cyprus, but in fact, it goes to show that a telescope, even in the suburbs of London, can still get quite a good image. So there's a lot of people have asked me, is it worth getting a telescope? I live in the city. Well, yes, it is. Some of the best images of the planets are actually taken by a chap called Chris Go, who lives in a flat in the middle of Manila, I think it is, in the Philippines, and he takes some wonderful photographs. So just because you're in the city doesn't mean to say you can't do any astronomy, and I think your image there shows that. I wonder if you would be able to do a quick process on that in the next couple of minutes. Maybe we could just go over to Mark and see if he's got anything else to show us up in Edinburgh. We sort of cut you off a bit there, Mark, didn't we?
No, that was pretty much the end of my video, so that was it. That was it for
Oh,
me.
okay, good, fine. Well, thanks
Nothing
very
live
much
here apart from clouds, I'm afraid.
Yeah, and we've also got Dave Eagle here in Northampton, who's been listening in, and I wonder if we can just have a word with you since we've got you there while David's maybe processing an image.
Evening, folks.
And you've got a lovely picture of your own behind there. One of the things we will be doing on another day is hopefully doing some deep sky stacking, which is something you're very good at, isn't it? So just give us a minute on deep sky stacking, how that works.
Oh, crikey. Well, a little bit like the planetary imaging we do, where we take lots and lots of images one after the other, and that's very much the same with deep sky images. although when you're doing planetary images, they're very, very quick captures to try and freeze the scene. But with deep sky images, you take longer exposures. So they're quite long exposures, but you take quite a number of images over the course of a time, many hours, and some people go to great lengths over many days, weeks, or even capture more data the next year the object comes into view, and then you stack those all together to produce the final image. So you get an image that looks something like this. This is the center of the Heart Nebula.
Yes, and at one time that sort of image again would have been impossible with amateur equipment when we were back using film. But I'm constantly amazed at the sort of images that people manage to bring up with, even from suburban skies using narrowband filters. It's extraordinary what people can do. Well, thanks, Dave. I hope we're going to hear from you on another occasion at live streaming. I wonder if we can go back to David now to see if he has actually got any live any stacked images to show us. I know it's a bit of a short interval. How are you getting on, David? You're muted, David. We can't hear you.
Oh yes.
There you go.
I have taken the image, but I haven't processed it yet. So it's and actually recorded it in the wrong folder, because I recorded it as if it's Jupiter, and it's not, it's Mars. So that's why it took me a bit of time to find it. But I will we'll take
maybe show it to us another day in that case.
Yes, we'll show it. We'll show it tomorrow. Yeah.
Okay.
Or another day.
And we've got some more live streaming coming up on the next few nights until tomorrow week. Actually, we've got live streaming each night, so we'll be looking at the way Jupiter is changing. We'll be looking at the way Mars is rotating, which it will do, as David says. It rotates a small amount compared with us. The two planets are going in synchronism, so we see more or less the same faces of Mars each night, but we do get to see a bit more of this. So we're hoping to get some really great images, and also we'll be looking at other things. The great red spot should be visible tomorrow on Jupiter. The Jupiter rotates in 10 hours, but that means that we don't see all of it every night, but it's pretty well every other night we get a different face of it. So hope you've enjoyed this evening's broadcasting. Tomorrow night your host will be Nigel Henbest, who's actually over in the States at the moment. He won't be showing you any live images from where he is in North Carolina, but he will be cementing the whole thing together and moving from one observer to the other. So we look forward to seeing you then. And tell your friends that we're doing this live streaming. We'd like to see lots and lots of people watching the scene. So thanks very much to Andy, Agapios, David, Mark, and Dave for doing that. Thanks also to Callum Potter of the BAA, British Astronomical Association, who has been doing the technical side of this. And I think it's been a very good technical show, because we just gone from one source to another without a hesitation or a hiccup. That takes a lot of doing on Zoom, I can tell you. I know only too well how things can go wrong. So thanks very much to everybody, and also to Les Brand for organising it. And we look forward to seeing you again tomorrow night, again at 7 o'clock, same time, same channel. Good night.